All right, so get ready because today we're diving deep into the fascinating world of solid-state lighting.
Yeah, LEDs and beyond.
Exactly, and we've got some really interesting research here, snippets about what the future of lighting tech might hold.
Oh yeah, it's pretty exciting stuff.
For sure, I mean, think color-changing materials, maybe even glow-in-the-dark roads.
Things are going way beyond just replacing those old incandescent light bulbs.
Absolutely, but maybe we should start there, with the basics. Everyone always talks about how LEDs are way more energy efficient, but I've never really understood, like, why. What makes them so different?
Well, it's all about how they generate light. Like, think about an old incandescent bulb.
Okay.
Electricity heats up the filament, right, until it glows, but in that process, you're losing a ton of energy as heat. LEDs, though, they use semiconductors instead.
Semiconductors, so like what's in our phones and computers and stuff.
Exactly, and they convert that electricity directly into light.
Wow, so no heat wasting step. I guess that's why they're so much more efficient.
Exactly. And it's those same semiconductors that actually determine what color the light is.
Oh, right, because I remember learned about wavelengths back in school.
Yeah. Each semiconductor material emits light at its own specific wavelength, which translates to a specific color.
So that's why you get LEDs that glow blue and others that are red, and then some that are that perfect warm white.
Precisely. Scientists can actually choose specific semiconductor materials, kind of like a recipe, to create LEDs in tons of different colors. Like gallium nitride will give you that cool blue light.
Uh-huh.
But if you want to get those warm reds, you need to combine aluminum and gallium and indium phosphide.
Okay, so it's like change the ingredients, change the color.
Exactly.
Cool. But I remember, those early LEDs, they always had that harsh kind of bluish light. Not exactly cozy.
Oh, yeah, that's true. The early ones definitely had that problem. And that's where phosphors come in, though.
Phosphorus.
They're materials that can absorb one wavelength of light and then emit a different one.
Oh, okay.
So if you coat a blue LED with the right phosphors, boom, you get a warmer, more natural-looking white light.
So it's like you're directing the light, transforming it from that blue into something that's much easier on the eyes.
You got it. And the technology has come a long way, too, especially with phosphors. Like, thanks to all this research in material science, now we have LEDs that can give you that same warm glow as those old incandescent bulbs, but without wasting all that energy.
So we get the ambience we want without sacrificing efficiency. That's amazing. But it sounds like this is way more than just swapping out old light bulbs, right? It's like a whole new way of thinking about light.
It absolutely is. This whole shift to solid-state lighting, or SSL, is totally changing how we light up everything.
I mean, just look around.
Exactly. Streetlights that last for years, brighter and more efficient car headlights, even our smartphone displays, it's everywhere.
And it sounds like this is just the beginning.
Oh yeah, there's so much more to come. Like, imagine light fixtures that can also purify the air. They'd use LEDs to activate certain materials that can actually break down pollutants.
Wait, so the light itself could be cleaning the air we breathe?
It's a pretty promising area of research.
Wow, that's incredible.
And then there's the potential to use light for data transmission.
Oh, like fiber optics.
Yeah, similar, but what if LEDs could create a whole network of data points within a room?
Okay, now that sounds like something straight out of sci-fi movie. Light is data. My mind is blown.
I know, it's wild, and it all comes back to material science. By understanding and manipulating these materials at the tiniest level, we're not just making better light bulbs, we're creating a whole new way to interact with light and the world around us.
It's pretty amazing, I gotta say. But, all this talk about efficiency and cool technology is great and all, but I'm also thinking about the sustainability side of things. LEDs aren't just good for our wallets, they're good for the planet too, right?
Absolutely. Like, think about it. LEDs last way longer than traditional bulbs.
So less waste ending up in landfill.
Exactly. Plus, they use way less energy, which means we're not relying as much on fossil fuels. And then a lot of LEDs also use fewer toxic materials, unlike some of the older technologies.
Like anything with mercury.
Right.
So when we choose LED lighting, we're actually helping make the planet a little bit healthier. It's win-win.
It really is, and this is what I think is so exciting. The innovations in SSL aren't just about making things brighter or cheaper. It's about completely rethinking our whole relationship with light.
I like that. So before we get too lost in the glow of the future, maybe we should look at some specific examples of how material science is actually making all of this possible in the real world.
That's a great idea. Let's start with something classic, ultramarine.
Oh, ultramarine. I love that color. I've always been fascinated by how, artists used to go to such lengths to get that perfect blue. But what does that have to do with LEDs?
Well, ultramarine gets its vibrancy from a unique molecular structure. It actually contains complex sulfur species. And understanding how those molecules interact with light, that gives us clues on how to design and make materials that emit specific colors which is super important for LEDs.
Oh, wow. So the same things that make ultramarine blue can be applied to creating the LEDs we use every day.
Exactly. It's a great example of how knowledge from different fields like art and chemistry can come together to create something new.
That's so cool. It's like there's beauty in science, too. Okay, so what about another example?
How about polyketides? They're natural compounds that come from bacteria and fungi,
Polyketides. Okay.
and some of them actually have some really powerful medicinal properties.
Really?
Yeah, they're like nature's little chemical factories producing all these complex molecules. And each step in the process adds a little chemical modification, and you end up with this huge diversity of molecular structures.
So, like, different structures mean different effects.
Exactly. And we're talking about some serious biological activity here.
So some of these polytides are being used to develop new medicines, like antibiotics or even anti-cancer drugs.
That's right. And what's really amazing is that by studying how nature makes these molecules, chemists are figuring out how to replicate and even modify those processes in the lab.
So we're learning from nature's playbook to make new medicines? I love that.
Exactly. Polytide research is a perfect example of biomimicry, using what we see in nature to spark innovation.
Okay, I'm starting to see a theme here. Nature as inspiration for technology. What's another example of that?
Well, how about mussels? They can cling to wet surfaces like nobody's business, and scientists are figuring out how to use that power to make new adhesives.
Right. Mussels are crazy strong.
They have these special proteins that let them stick to all kinds of things, even in rough ocean conditions. And it turns out these proteins are full of something called catechol, which can form strong bonds with tons of materials.
So scientists are basically copying mussels to make adhesives that work underwater or even in the human body. I can imagine all sorts of cool uses for that.
Exactly. We could use them for wound closure, attaching implants, even for underwater repairs. It's pretty incredible.
Wow, mussels really do have sticking power. So it seems like nature has a lot to teach us about material science.
It really does, and it highlights a key point. Sometimes the best solutions to our problems are right there in the natural world.
You know, all these examples are blowing my mind. It's amazing to see how material science is everywhere, impacting so many different parts of our lives.
Right, and this is just the beginning.
We've got so much more to cover in our deep dive into the world of solid-state lighting and beyond, so stick around. We'll be back with more mind-blowing insights.
You know, thinking about all those incredible examples we just talked about, it really makes you realize how even the tiniest things can have a huge impact. Like, take microRNAs, for example.
MicroRNAs, aren't those like super tiny pieces of genetic material? What do they have to do with lighting?
Well, not directly with lighting, but they kind of illustrate a point. You know, the power of small things. MicroRNAs might be tiny, but they're crucial for controlling gene expression. Almost like a dimmer switch, they regulate how much protein gets made from a particular gene.
Oh, so they're like the stage managers of our cells, making sure everything runs smoothly.
That's a great way to put it. And it's kind of like with LEDs, right?
How so?
Well, like how tiny tweaks to the semiconductor material can completely change the color of the light. Small changes in microRNA activity can have a huge effect on what happens in a cell.
I see. So it's all about understanding how to manipulate those tiny parts to make big changes.
Exactly. And speaking of tiny but mighty, we got to talk about graphene.
Graphene, yeah, I've heard of it, but I don't really get what all the hype is about. It's just a single layer of carbon atoms, right?
It is arranged in this honeycomb pattern, but it's got some truly amazing properties. Like, it's super strong.
Stronger than steel.
Way stronger, like 200 times stronger, and it's unbelievably thin and flexible, and a fantastic conductor of electricity and heat.
Okay, yeah, that's pretty impressive. But how does this tie back into lighting?
Well, think about those super thin and flexible OLED displays you see on phones and TVs. Graphene is perfect for making flexible electronics, including the ones used in some pretty advanced lighting applications.
Ah, so we could create lighting that can bend and change shape. I bet designers would have a field day with that.
For sure. And because it's such a good conductor, it could also lead to even more energy-efficient LEDs and lighting systems.
You know, now that you mention conductivity, it reminds me of melanin.
Melanin, you mean the pigment that gives that skin and hair its color?
Yeah, but I remember reading that it also has some interesting electrical properties, like it could absorb and dissipate energy, almost like a natural semiconductor.
That's right. Melanin structure is actually really good at capturing light energy and converting it. That's why it's so good at protecting our skin from UV radiation.
Right, right.
And some researchers think that if we can really understand how melanin does this, it could lead to breakthroughs in organic electronics.
Like even more efficient solar cells?
Potentially, yeah. Maybe even new types of LEDs.
Wow. Harnessing the power of melanin for lighting. That's pretty amazing.
It is, and it just shows how exploring these natural materials can lead to some really cool new technologies.
Right, like those muscles we were talking about before, their sticky powers could also be used to make better ways to manufacture and assemble lighting components.
Exactly. More durable, more sustainable. It all ties together.
It's like we're using nature to fix the problems caused by technology. I love that.
Yeah, it's a great example of how understanding biology can inspire solutions in tech.
So back to LEDs for a second. You mentioned earlier that they could be used to transmit data. How does that even work?
It's called Li-Fi, short for light fidelity. Basically, you rapidly change the intensity of the LED light, and that creates data signals.
So the light itself carries the data, like Morse code with light.
Kind of, but way faster. It happens so quickly we can't even see it. But a receiver with a special photodiode can pick up those tiny changes in light intensity and translate them into data.
Wow, that's crazy. What are the advantages of using Li-Fi over Wi-Fi?
Well, for one, Li-Fi is way faster, and it can transmit data further, too. It's also more secure because light can't go through walls, so it's harder for someone to, eavesdrop.
Oh, that's a good point. So no more worried about nosy neighbors stealing your Wi-Fi.
Ha! Exactly. Plus, Li-Fi can use the lighting we already have, so it's potentially more energy efficient, too.
So LEDs could change how we use the internet. That's incredible.
It is, and it's just one example of how solid-state lighting is really pushing the boundaries of what we can do with light.
I'm loving all of this, but I'm not going to lie. I'm starting to feel a little overwhelmed with all this information.
I hear you. It's a lot to take in. Maybe we should zoom out for a bit and think about the bigger picture.
Yeah, good idea.
Okay, so we've been talking about LEDs and materials and all that, but it's important to remember that this is all part of something much bigger, this shift towards sustainability and a circular economy.
The circular economy, I'm not sure I've heard of that.
It's all about eliminating waste and pollution. The idea is to keep materials in use for as long as possible, design products that are durable and recyclable, move away from that take, make, dispose model.
Sounds a lot more sustainable than what we're doing now. So how does solid-state lighting fit into that?
Well, LEDs are a good start because they're so much more energy efficient and longer lasting than those old types of lighting. But the real game changer would be to integrate LEDs into a truly circular economy model.
So designing lighting systems that can be easily taken apart and repaired, upgraded, recycled.
Exactly. It's not just about the materials themselves, it's about designing the whole system with sustainability in mind.
That makes sense, but how do we actually make that happen? Seems like a pretty big challenge.
It is a huge challenge, but it's doable. We just need to get creative with our designs, collaborate across different fields, and really invest in research and development. It's not enough to just swap old tech with slightly better stuff. We need to rethink how we design and make things from the very beginning.
So it's a call to action for anyone involved in the lighting industry, right? Scientists, engineers, designers, everyone.
It is, and it's also a call to action for us as consumers. We have power too. We can choose sustainable products, support companies that are doing things the right way, and push for policies that encourage innovation and protect the environment.
Right. It's a team effort.
Exactly. And it's really exciting to see how all these innovations in materials and technology are giving us the tools to create a more sustainable future.
This deep dive has been quite the journey, from those tiny microRNAs to the big picture of a circular economy. It's amazing to see how it's all connected.
It is. That's the fun part, right? Making those unexpected connections and seeing things from a new angle.
For sure. And speaking of exploring, we're not done yet. There are so many more fascinating materials and technologies waiting to be uncovered. Ready to keep diving deeper.
Always. What's next?
Let's shift gears a bit and explore some of those cutting-edge materials that are really pushing the limits of what we can do with light. We're talking liquids that act like solids, materials that can change color on demand. There's a whole world of wonders to discover. All right, so are you ready to explore some seriously mind-bending materials?
Let's do it.
We're talking about things that are shaping the future of lighting, stuff that seems like it's straight out of science fiction.
Yeah, stuff that changes color like a chameleon.
Exactly. We've talked about solids and semiconductors, but what about a liquid that acts like a solid? Have you ever heard of that?
A liquid that acts like a solid. It might sound crazy, but they're real. They're called liquid crystals.
Liquid crystals.
Yeah, they can flow like a liquid, but still have that molecular order of a solid.
Okay, I'm trying to picture that in my head. How can something be fluid and structured at the same time?
Think of it like a school of fish.
Okay.
All those fish, they can move around freely, but the whole school keeps a specific shape, right?
Yeah, I see what you mean.
It's similar with liquid crystals. The molecules can move, but they line up along a certain axis, so you get some of the properties of a solid.
That's a great analogy. So what do liquid crystals have to do with lighting?
Well, they're a key part of LCD displays.
Oh, right, LCD liquid crystal display. So those screens we use every day are using these weird materials.
Exactly. And as LCD technology keeps getting better, I think we'll see even more cool applications in lighting.
Like what?
Flexible displays, transparent ones, maybe even light panels that can change color and shape whenever you want.
So you're saying we could have walls that light up in different colors? Or ceilings that show moving images?
Who knows? The possibilities are pretty much endless.
That's wild.
And speaking of color-changing materials, there are also these things called photochromic materials.
Photochromic materials. What are those?
They can actually change color when they're exposed to light.
Oh, like those transition lenses that get dark in the sun?
Exactly. They have these molecules that change their structure when certain wavelengths of light hit them.
So the light itself triggers the color change.
Yep. And it's reversible, so when you take away the light, they go back to normal.
So could you use these to create lighting that, like, reacts to the amount of daylight in a room or changes color based on your mood?
Exactly. Imagine a room where the lights change with the time of day, or even react to you being there.
That would be so cool.
And that's just the start. Researchers are looking at photochromic materials for energy-efficient windows, smart clothes, even data storage.
Wow. It sounds like they could change a whole lot of industries, not just lighting.
Definitely. And they're a great example of how exploring materials can unlock all these crazy possibilities.
This whole deep dive has been so eye-opening. It's incredible to see all this potential in solid-state lighting and material science. We've gone from semiconductors and phosphors to liquid crystals and photochromic materials. It's amazing how it's all changing the way we light up the world.
And we've barely scratched the surface. There's still so much to discover.
That's what makes it so exciting, right? As researchers keep digging deeper into these materials, who knows what amazing things we'll find.
Who knows, but I'm sure it'll be incredible.
So as we wrap up this deep dive, what are some of the big takeaways you hope people will remember?
I hope they come away with a sense of wonder about all these different materials out there and their potential, and just an appreciation for how material science is changing everything from lighting to medicine to sustainability.
Well said, and I hope everyone listening is inspired to keep exploring, keep learning, keep asking questions about this amazing world of materials that we live in.
I agree.
Until next time, keep shining bright, everyone.